Good morning, one and all. My name is V. Abhijit Kumar. My roll number is 24951A6602. I am studying in CSC, AI and ML, that is Computer Science and Engineering, with a specification of Artificial Intelligence and Machine Learning, third semester, BTech second year, Institute of Aeronautical Engineering. In this AIT Tech Talk of the subject of operating systems, I am going to talk about the topic of recovering internet service sessions from operating system failures. Now let's go through the contents. First of all, in the first place, I'm going to introduce the topic, and after that I'm going to explain about the session semantics and failure modes, and after that I'm going to explain about the stateless by design and externalized state services, and after that I'm going to explain about the transport layer techniques, and after that the processes of CRIU, the checkpoint or restore of those processes. I'm going to explain about that, and after that VM or container snapshots and orchestration. I'm going to explain about that, and after that I'm going to explain about reconciliation and exactly once semantics, and after that security and compliance during recovery. I'm going to state about that, and after that we'll go through a case study and its benchmarks, and after that I'm going to conclude the topic. Now let's go through the introduction. First of all, recovering internet service sessions from operating systems failures. Basically, the operating systems, they manage active internet sessions. For example, browsers, apps, servers, etc. They have a lot of failures like crashes, power loss, kernel panic, etc. Those failures interrupt these sessions, and the recovery ensures continuity. It minimizes data loss and restores user state. And the key goal of this entire topic is to maintain seamless service despite the system breakdowns. Hence, this is the introduction. Now let's go through the session semantics and failure modes. We have to get clarified about what must survive a crash, because the transport sessions might be renegotiated, but app sessions often need continuity. The RTO and RPO, they must be defined, and monitoring is essential to trigger the right responder. First of all, I would like to state four important aspects over here. First aspect is transport versus application sessions. It includes TCP or QUIC connection state versus login tokens, cards, cursors, and transactions. And after that, failure modes. It in, they include kernel panic, power loss, driver deadlock, file system corruption, container or VM host crash, etc. And after that, observability. The entities which drive automated recovery are the key aspects of observability. Say for example, watchdogs, kernel oops logs, heartbeats, failure detectors which drive automated recovery. And after that, RTO or RPO targets. They include two targets. First target is to restore connectivity, the time to restore connectivity versus acceptable state loss, and after that tail, tail latency implications. Hence, these are the session semantics and failure modes. Now let's go through the stateless by design and externalized state services. Now, stateless services recover the fastest. We have to emphasize idempotency, exactly once illusions by at least once plus dedupe and careful key design, client ID plus op ID. Load balancers can avoid broken affinity if the state is externalized. First of all, push session state to external stores like Redis, Memcached, DB, etc. with TTL and replication IT results in fast restarts. And after that, idempotent operations and request replay guards, which are deduplication keys. They mitigate duplicates after recovery. In sticky versus non-sticky balancing, the tokens or cookies carry essential context like JWT, opaque session IDs, etc. During trade-offs, the latency to state store consistency model, which are both eventual and strong, and cost of replication occur a lot. Hence, these are the services, the stateless by design and externalized state services. Now, let's go through the transport layer techniques. First of all, I would like to explain why QUIC requires reconnection or connection IDs. TCP lacks transparent migration. Applications must retry. Hence, zero RTT improves perceived continuity but demands replay protection, which include anti-replay windows, binding to addresses, etc. First of all, these techniques are four techniques. First one is TCP, which includes time wait aspects, sequence numbers, failure implications, and connection reset versus transparent reconnection patterns. And after that, QUIC technique. It includes user space transport with connection migration, zero RTT resumption tickets, better cache resilience. And after that, TLS or PSK technique. You have to be careful with replay risks and blind to client properties. And after that, the middle boxes or NATs. They keep alive strategies to preserve mappings during recovery windows. Hence, these are the transport layer techniques. Now let's go through checkpoint or restore of processes, which is abbreviated as CRIU. Here we have to detail how CRIU walks VMAs, dumps FDs, and TCP stack state. The cross-kernel restores are fragile. Orchestrators must quench dependencies to avoid inconsistency. We have to evaluate cold versus warm restore times. CRIU preserves process memory. It preserves descriptors, it preserves TCP sockets, hence they restore after kernel restart or migration. Here I would like to state about three major aspects of CRIU. First aspect is requirements. Requirements include kernel compatibility, frozen file system state, and coordinated pauses all across dependent processes. And after that, limitation. The kernel version coupling is one of the main important limitation. The device driver state and RDMA or accelerator handles, which often do not restore, which are often not restorable. It is also a limitation. And after that, the use cases. Low latency trading or stateful proxies that must resume sockets with minimal downtime. Hence, this is the slide where I had explained CRIU successfully. Now let's discuss about VM container snapshots and orchestration. Here we have to discuss about infra-level approaches, snapshot cadence versus performances, replication lags, and traffic shift mechanics. They combine with WAL or transaction logs to reapply or roll back last operations safely. The hypervisor snapshots, KVM or VMware, and container checkpoints provide coarse-grained session continuity. Warm standbys, active clusters. They fall over via any cached or DNS with low TTL. Low TTL occurs, and it results in health propagating. The persistent volumes and write-ahead logs WALs to reconcile in-flight mutations post failover. The chaos testing, fault injection. Chaos testing and fault injection are both the same terms. They validate recovery paths and SLO adherence. Hence, this is the slide of VM container snapshots and orchestration. Now let's discuss about reconciliation and exactly once semantics. Here I would like to emphasize that exactly once is built atop idempotency, thus deduplication. The outbox patterns prevent dual write anomalies and guarantee replay safety after the crashes. Hence, at least once, the delivery with reduced keys, it should be done for the sake of transactional outbox pattern to align DB plus message broker. The idempotent endpoints include put semantics, sequence numbers, and CAS guards or compare and swap guards. The sagas and compensating actions for multi-service workflows occur. Hence, the budgets must be retired and strategies must be backed off. The observability we can trace correlation IDs. The correlation IDs across retries to debug duplicates or losses. Hence, this is the slide of reconciliation and exactly once semantics. Now let's discuss about security plus compliance during recovery. The security often weakens during emergencies. Hence, we have to keep the key material sealed and we have to rotate the tokens if compromise is suspected. We have to maintain auditable, repeatable procedures for compliance frameworks. Token invalidation on restore versus seamless continuation results in risk-based decisions for re-authentication. We have to protect secrets on disks, which include KMS, sealed vaults, etc., to avoid exposure during snapshot or restore. The audit trails. We have to record who or what performed recovery. We have to tamper evident logs, the incident response runbooks. We have to record everything in order to maintain the security. And for the sake of user privacy, we have to avoid restoring private ephemeral buffers unless consented or necessary. Hence, this is the aspect of compliance during recovery. Security and compliance during recovery. Now let's go through a case study and its benchmarks. First of all, the e-commerce cart service. It is actually a sum of externalized session store and QUIC clients, which results in sub-second recovery with zero cart loss. The stateful reverse proxy with CRIU includes two aspects. First of all, the 85% of sockets, 85% of sockets, they are resumed and they fall back to fast reconnect for remainder. And the benchmarks include three. First of all, the RTO P99 is lesser than 2s. The duplicate request rate is lesser than 0.1%. The negligible revenue impact is only and only during chaos drills. Hence, the lessons here are to combine stateless design for most flows with targeted stateful restore where latency is critical. We have to provide concrete numbers and blended strategy, and it is a main point that not every component needs CRIU. The reserve, we have to reserve for parts where milliseconds matter. Hence, this is the case study. Now, in the last place, let's conclude this topic. Hence, the recovering internet service sessions from operating system failures is very essential to ensure seamless connectivity, protect user data, and minimize downtime. It strengthens system reliability, it maintains user trust, and it supports uninterrupted online activities. In short, the recovery mechanisms make operating systems not just fault tolerant but user friendly and dependable in the digital age. Hence, this is the conclusion. And finally, I would like to sincerely thank the respected professors who had given me this wonderful opportunity to speak upon this wonderful topic. Thank you.